This part of the test will measure your listening ability when it comes to the conversations and lectures in academic settings. You will listen to a recording, and then answer questions about it. You will be able to take notes while listening, and you can listen to the recording only once. The questions must be answered in the presented order. During the exam, you will not be allowed to go back to the previous question. Now listen to the lecture.
Good day, students. We'll talk about the foundations of electric motors today. Electric motors are essential parts in many industries because they transform electrical energy into mechanical energy. The several kinds of electric motors, their working theories, and their applications will all be discussed in this lecture. Let's first talk about the fundamental categories of electric motors: direct current or DC motors and alternating current or AC motors are the two basic kinds. While AC motors use a variable voltage source to produce a sinusoidal torque waveform, DC motors imply a constant voltage source to produce a continuous torque. Brushed and brushless DC motors are the two most popular varieties. While brushless motors use electronic commutation, brushed motors use physical brushes to deliver current to the rotor. Increasingly, more people are using brushless motors because of their excellent efficiency, low maintenance requirements, and long lifespan. DC motors are frequently used in electric cars, toys, and a variety of home products. Synchronous and induction motors are the two main categories of AC motors. The speed at which synchronous motors run is directly proportional to the supply frequency. On the other hand, induction motors employ electromagnetic induction to generate torque that is a little bit slower than the supply frequency. Industrial settings, pumps, fans, and other large-scale applications frequently employ AC motors. It's crucial to comprehend the fundamental operational ideas of electric motors. Electromagnetism, which asserts that an electric current produces a magnetic field and that a magnetic field can induce an electric current, forms the basis of how electric motors work. An electric motor's rotor, which houses the conducting windings, is its most important part. A magnetic field is produced as electric current passes through these windings, and this interaction produces a mechanical force that propels the rotor into rotation. The stator is also a crucial component of electric motors. Either permanent magnets or electromagnetic windings are present in the stator, which surrounds the rotor. To create torque in a motor, the magnetic fields of the stator and rotor interact. The motor design, voltage, and current are only a few of the variables that affect the torque produced. Electric motors are essential to contemporary life because they offer a safe, dependable, and efficient way to transform electrical energy into mechanical energy. Electric motors are now more effective and compact thanks to technological developments, which enables their incorporation into a greater variety of applications. Electric motors will only become increasingly essential to our daily lives and industries as long as we keep innovating. In conclusion, electric motors are crucial elements in the process of converting electrical energy to mechanical energy. They can be divided into two groups: DC motors and AC motors. Every kind has particular operational ideas and uses. Electromagnetism is used by electric motors to produce torque, which eventually powers their mechanical motion. Electric motors will continue to play a bigger and bigger role in our lives as technology develops. Electric motors will only become increasingly essential to our daily lives and industries as long as we keep innovating.
Now listen to the conversation between two people.
Good morning, Alex. I just finished reviewing your latest essay, and I have to say, I'm quite impressed with your analytical skills.
Thank you, Professor Smith. I'm happy to hear that you liked it.
Your talent in this area is truly remarkable. I can't help but think that you would have a bright future in geology. Have you considered pursuing a career in this field?
Well, I do enjoy studying geology, but I haven't seriously considered it as a career option yet.
I understand that choosing a career path can be daunting. However, with your abilities, you could make significant contributions to this field. You might even have the opportunity to make a big discovery one day.
That's a fascinating thought, Professor. But I feel I need to explore other possibilities before making a decision.
That's a wise approach. I just wanted you to know that I see great potential in you. And should you decide to pursue geology, you can count on my support.
Thank you, Professor Smith. I truly appreciate your confidence in me. I will definitely keep your advice in mind as I consider my future.